State and prove the Cauchy's residue theorem statement. Let f of z be an one valued analytical insight and on a closed contour C except at a finite number of poles z1, z2, so on zn, and let r1, r2, and so on rn be respectively the residue of f of z at these poles. Then integral f of z dz is equal to 2 pi iota bracket starts r1 plus r2 plus so on r plus rn bracket close. Now proof. Let c1, c2, and so on cn be the circles with the centers at z1, z2, so on zn respectively, and the radii so small that they lie entirely within a closed curve C and do not overlap. Then f of z is analytical within the range and closed the curve C and the circle. Hence, by Cauchy's theorem, the multi-connected range we have integral f of z dz, integral c1 f of z dz plus integral over c2 f of z dz plus so on integral of c over cn f of z dz. But r1 is equal to 1 upon 2 pi iota integral over c1 f of z dz by the definition of the residue, or integral c1 f of z dz is equal to 2 pi iota r1. Similarly, integral c2 f of z dz is equal to 2 pi iota r2, and so on. Hence, integral over c f of z dz is equal to 2 pi iota r1, 2 pi r2, and so on 2 pi rn, which is equal to 2 pi iota bracket starts r1 plus r2 plus so on rn, or integral over f of z dz is equal to 2 pi iota sum of the residue at the poles within